Alright, ladies and gentlemen. Now, in this video, we'll be reviewing set. So, we'll touch out every single point, every single thing you need to know on set. Now, what is set? Set is a collection of well-defined objects. Objects in the sense that not necessarily only objects. Now, let's say the whole student of Lagos State University, we are set of Lagos State University. The set of Unilag students, the set of other schools, the set of primary school students. So these are set. So it is a collection of well-defined objects. Now, another example is all accounting students in the Faculty of Management Science. This is also a set. We have a math set. So that's the simple definition of set. Now, the set of natural numbers. Before now, you should know what natural numbers are, what real numbers are, what whole numbers are, what positive integers are. Now, is an example of infinite set. When we say something is an infinite set, that is, it keeps on going 1 2 3 4 5 6 up till infinity, so it has no end. That is infinite set. So for the otherwise, the second one is finite set. Those ones that the number of elements is countable, those ones are finite set. A very example is, you see, the set of even numbers less than 10. The set of even numbers less than 10 are 2 4 6 and 8. You understand? So this is an example of a finite set. Why the other one, the set of integers, the set of natural numbers start from 1 up to infinity. Now, you should also note that all the sets that we have must start with a capital letter, must be represented with a capital letter. So if you see a question and you see the question is being represented with a small letter, know that it is not a set. So, and it is also represented with what? With a curly bracket. Now, moving down to the membership of a set. When we say, look at the set of natural numbers, for example, 1 is a member, 3 is a member, and you can see I write it boldly there that 2 belong to the set of n. That simply means that 2 is a member of natural numbers. But look at natural number, you see that there is no 0 there. So we can say that 0 is not a member or does not belong to the set of natural numbers. So that is the representation, that is how we read it. So that's the membership of a set. So now let's move to the set notation. Now, set notation, we have two ways in which we represent set. That's the roster method or enumeration method. We also have the set builder notation method. Now, the roster method is just the normal way of representing set. You see, the set of positive odd numbers, so they are 1 3 7. We just represent them in a curly bracket. But the set builder notation is just, we represent it using some notation entirely. So we have it to be a equals to the set of x. That is how we read it. A equals to the set of s such that s equals to 2n plus 1 and n belongs to the set of positive integers. So that statement there, that is just what I just finished reading. That's just what I finished reading out now. So you'll notice that if you put n equals to 0, n equals to 1, n equals to 2, n equals to 3, back to 2n plus 1, you will still arrive at a equals to 1, 3, 5, and 7. So that's the difference between the set builder notation and the roster notation. Now, we move to set classification. Now we have a singleton set, that is a single set. So it's a set that has just one single element. So be it 1, 2, 3, any, so far it is, that's just one single element or one member. So empty set or null set or void set. So those ones are the set that does not contain any element. So those ones are null set. Then proper set and subset. Most students usually confuse these two sets together. Now let's say A is 1 2 3 4, B is 1 2 7.
Now B is a proper subset of A. You notice that B is 1 to 7. So it means that B contains at least two elements that is in A. So it is a proper subset. Now, if it is now a subset, it must contain all the elements. I repeat, it must contain all the elements in B. So you see that 1 and 2 is contained in A. So if we the reason why I'm using the statement containment is because in a subset is also known as what? A containment. You understand? So that is that. Now we move to power set. Now the number of power set equals to 2 raised to power number of elements in a given set. So let's say we have A to be 1 to 3. The number of power sets is equals to 2 raised to power 3, and 2 raised to power 3 is what? A. Now you have to look for a way such that all the elements that you have must contain 8. So we have 1 2 3. So the first thing you need to start from is the empty set. After the empty set, the 3 set. After the 3 set, you pick 1 2, we pick 1 3, 2 3, we pick 1 2 and 3. You notice that if you add all of them together, you have what? 8. So that is a power set. So the number of cardinality in a given set is raised to power of of n to have our power set. Now we have operation on set, we have the union, and we have the intersection. The intersection simply means the common term between the two sets or between the three sets. You understand? Why union is just the combination of all the sets that we have. So don't, when reading for set or solving questions on set, don't expect to have only A B alone. You can have A B and C. You can even have 4 different sets, but note that all sets must start with what? Must begin with a capital letter. It must be represented with a capital letter. Alright, so we move to mutually exclusive. Mutually exclusive are those sets that when you take the intersection, they have nothing in common. So if you have two in Venn diagram, if we have two different cycles that are not intersecting, so those are mutually exclusive or disjoint set. You understand? So that's it. Now for the universal set, you get to understand the universal set better while treating the complement of a set. The complement of a set is given as A subtracted from the universal set, or the universal set subtracted from A. Now we have our universal set to be 1 to 8, and we have A to be 137. Now if you take 137 from the universal set, you are left with 2 5 6 7 and 8. So you can see now that you understand what a universal set simply means. So to deal with a complement, the complement of a set, you must be given a universal set. Now set difference. Now set difference is just difference between two things entirely. You understand? Just like 5 minus 3, that's 2. Now 1 2 3 4 is A, 1 4 7 is B. Now to take B from A, you see that when you take all the elements, when you take 1 and 4, 1 and 4 is in B, so we take it out from A, so we are left with 2 and 3. Now the same thing as B minus A, B minus A, so B minus A is equals to 7. If you take 1 4 from B, you are left with 7. So that's set difference. Now symmetric difference, know that set difference is not commutative. That is, A minus B is not equals to B minus A. Now symmetric difference is the intersection of set difference. You understand? Symmetric difference is the intersection of set difference, where that symbol is representing delta. So if the union of not intersection, the union of set difference. So if you take the union of A minus B, you know, in the previous slide I explained what union means to you. So you bring everything together. A union B, A union B should give you 2 3 and 7. So we have 2 3 7. Alright, so guys, we come to the Cartesian product. Cartesian product, you can see that
when you multiply A times B, A is in A and B is in B. You understand? So it's just normal multiplication. 1 times A, 1 times B, 2 times A, 2 times B. Now we also have some important properties. Take note of those properties very, very well. Very, very important. And they have provings, but of course, some students are required to prove why some are not. Now we have a solved example here. We have our universal set, we have our x, we have our y, and we're asked to look for s prime intersection y and x u y prime. So we have our final solutions to this. So they are it's very straightforward, very straightforward. So that is it. So we take the last example on Venn diagram now. Take the last example on Venn diagram. So we have the example to be, we are asked to look for the value for x. So all we just need to do is to add all the elements together and we equate it to the universal set, and we look for the value of x. You see that if you add x back, you still get 35 as your final answer. The solution to the assignment given. So that is the answer. You add everything together. You do 80 equals to 65 minus x plus 50 minus x, and you make x the subject of a formula. At the end of the day, you should have your value for x to be equal to what? To be equal to 35. To be equal to 35. So this is where we'll pause for this video. Thank you for watching, and for those of us that have not subscribed, kindly click on the subscribe button and share, like, and comment as well. Thank you very much. For lastly, when solving for Venn diagram question, the best thing to do is to look for the intersection first. That is just the key concept behind Venn diagram. Look for the intersection first, then you are good to go.